A huge meteorite enters our atmosphere, causing an explosion of catastrophic proportions. All forms of life on Earth cease to exist. A giant wave of fire wraps around the planet several times until only ash and dust remain of the green landscape.
But then again, there's another option for our planet's future. The sun could swallow it.
Wait. Who is this?
In the course of its evolution, our star will keep expanding.
Am I the only one hearing this voice?
Until it gets so big that it just swallows our planet without even noticing it.
Hey buddy, that's my video.
I don't think so.
Okay, alright, I'll share it with you. But let's not look that far into the future.
Whatever you say, buddy. How about the fact that the Earth will soon have rings?
Like Saturn?
Almost. Saturn's rings are made of dust and ice.
Yeah, I've heard about that. Thousands of years ago, something really mysterious happened in Saturn's orbit. The planet's gravity tore one of its satellites apart.
Yes, Saturn is a gas giant. It's 95 times heavier than Earth, so it has stronger gravity. It attracted a small moon from its orbit to its surface. Then, it was torn apart from the inside by tidal forces, like the ones between Earth and Moon. Many huge fragments stuck in Saturn's orbit. Some scientists say there was a collision of two moons there. They crashed into each other like billiard balls. As a result, both cosmic bodies turned into a pile of debris and blocks of ice.
No matter how they got there, this debris started circling Saturn. They collided with each other, turning into smaller rocks. It was a kind of cosmic blender. Rocks gradually ground into dust, and huge blocks of ice turned into small crystals. On average, the objects are in the same ratio to these rings as a human fingernail to a school bus.
And soon, similar rings will appear around Earth.
But how? I mean, we have the moon, and it's hard to imagine that it could break apart at any moment. Plus, we don't have another moon to recreate the same collision in our orbit.
Space junk. We have a lot of it. We started launching spacecraft into Earth's orbit in about 1957, and it almost always follows the same scenario.
Ah, yes. The rocket consists of several parts, a booster, or even several of them, the second stage of the rocket, and a cargo, which is contained in a capsule at the end of the rocket. The booster accelerates the rocket to almost orbit and then undocks. The second stage fires up the engines and climbs even higher to get the cargo into orbit. Then the second stage undocks as well, and the cargo capsule releases the satellite or space probe into outer space.
Yes, the first and the second stages of the rocket and the cargo capsule were disposable. That means they stayed in Earth's orbit. Over time, our planet attracted them. They entered the atmosphere and burned up because of friction with the air. But many objects keep orbiting our planet for decades. As of 2021, there are about 170 million space debris objects in our orbit. These are parts of spacecraft, like the bolts used to undock rocket stages. There are also old artificial satellites, operating ones, functioning spacecraft, and debris from collisions that had already happened.
Oh, I've heard about that. In 2009, two satellites collided with each other. Both satellites were destroyed. They shattered into about 600 pieces of different sizes.
Yes, and these sharp metal fragments are flying in orbit at about 6 miles per second. So they could make a trip from New York to London in less than 10 minutes.
Yeah, that's about the same speed at which our rockets fly. And that's about 45 times faster than commercial airplanes.
So these fragments have a lot of energy. As they collide with each other, they shatter and become smaller.
Just like the moon debris around Saturn.
Exactly.
But a bunch of metal debris orbiting faster than the speed of sound can damage our spacecraft, right?
Yes. The International Space Station has already turned on its engines to maneuver once to avoid a collision with a cloud of space debris. Sharp metal parts can damage the hull of the space station or even puncture it. Then the ISS, worth about $150 billion, would be destroyed.
So, if we keep throwing debris into orbit, we could really give our planet the rings.
And then they will be visible even during the day. They will reflect sunlight, just like the moon. And if you look out the window, you'll see beautiful stripes interrupted by the shadow that the Earth casts.
It's an amazing view. Do you want to see an even more unusual one? Imagine that our sun has increased in size by 10 times, and that process is happening right now. Our star is a giant boiler burning hydrogen. It's continually heating up, and every billion years, the sun gets 10% brighter and creates more heat. It'll heat the Earth more, and eventually, the oceans and seas of our planet will begin to evaporate, Thick clouds will completely cover the sky, turning Earth into a giant greenhouse. Our home will look like Venus.
Looks like humanity will no longer be able to live on Earth. What will we do then?
Well, we'll load all the humans and animals into spaceships and move to Mars. At that point, the sun will have warmed it up nicely. Water and carbon dioxide deep in the planet's interior will begin to evaporate and create an atmosphere there. This will cause a greenhouse effect and warm up the planet enough for you to wear shorts there.
And then we'll watch the Earth become a lifeless rock with acid clouds like Venus from the surface of Mars.
Yep, but in about 7 billion years, the sun will start to expand even more and become a red giant. In this phase, it'll become 256 times wider than it is now. So it will completely swallow Mercury and Venus, and the edge of the star will lie just in the orbit of Earth.
So our planet will just drown in the hot plasma on the sun's surface?
Maybe. But when a star burns so much fuel, it loses weight, and so the sun's gravitational field will weaken as well. So it won't keep the planets of the solar system as close to itself anymore. Perhaps our planet's orbit will become wider, and then Earth will become the first planet near the sun. Some scientists believe that at this time, Saturn's moon Titan may gain conditions suitable to become a new home for humanity. Then the sun will begin to shed its upper layers. It'll lose mass and gravity dramatically. This will plunge the solar system into chaos.
Some planets will collide with each other. Others may just fly away into the far dark space. It would be a game of cosmic billiards.
Exactly. And the final stage of the sun's life is a white dwarf. Then our star will become the size of Earth. The planets that survive won't get enough heat from the white dwarf, and its light will gradually fade over billions and trillions of years.
Another challenge that awaits Earth in the distant future has a galactic scale.
The collision of the Milky Way and Andromeda.
Bingo! Right now, the Andromeda Galaxy is moving toward us at 60 miles per second. You could make a trip around the globe at that speed in just 6 minutes.
Yeah, you can already see the stars and gas of Andromeda Galaxy in the night sky with an unaided eye at 2.5 million light-years from Earth.
And in 4 billion years from now, the galaxies will begin the process of merging. No one could be 100% sure about what will happen to the Earth. It could be total chaos when the stars and nebulae of both galaxies collide. Then supernova explosions would go off everywhere. Like fireworks.
But this is extremely unlikely to happen. The concentration of stars and space objects in galaxies is very low. The distances between them are gigantic. It's like if you took a handful of sand and scattered it all over the planet.
The most likely scenario is that by the time the two galaxies do collide, there will be no liquid water on the hot surface of Earth. That would mean the end to all terrestrial life. Scientists believe it can happen in about 3.75 billion years.
Why do we love Saturn so much? Right, because we love its amazing rings. The planet stands out in the solar system because of them. The major rings have a diameter of 170,000 miles, yet their thickness does not exceed 330 feet. Saturn's slowest outermost ring spins at about 37,000 miles per hour. It's slower than the rotation of Saturn itself. But did you know that Saturn was ringless for most of its history? Let's find out how they were formed. Using Cassini's final plunge into the planet, researchers could estimate the ring's mass, 33 billion pounds. Further, they have determined that the rings were between 10 to 100 million years old, much younger than the planet itself. The thing is that the rings only look solid. They are made of billions of rock and ice chunks. They are primarily tiny ones, looking like grains of sugar to those as large as a house, or even as mountains. The innermost chunks of ice and rock shoot through space at about 52,000 miles per hour. There are mysterious spokes in its rings. It seems they form and disperse within a couple of hours, and these spokes might consist of electrically charged sheets of tiny particles formed when small meteors hit the rings, or maybe electron beams from Saturn's lightning. One theory says Saturn's rings have formed all that extra material that remained after Saturn began, which is a material that couldn't create a moon. There's also a theory that says there was Theia, a Mars-sized planet that collided with Earth about 4.5 billion years ago. Lighter crust parts ended up in space during the impact, whereas its denser core stayed behind. But in the case of Saturn, all that debris perhaps didn't put a new moon together, but it formed rings many people today recognize this planet for. Another theory is that rings formed from dust and debris of a moon that ended up destroyed by this big impact, maybe by an asteroid or comet. Or perhaps the rings are there because once a moon fell apart because of the tidal forces coming from its parent planet itself. If these rings formed at the same period as Saturn did, they would have had more than 4 billion years to collect a bit of debris and dirt coming from micrometeorite collisions. But these rings mainly consist of water ice, no dirt at all, which means they're younger than expected. And the nature of this ring system tells us a thing or two about Saturn's fuzzy inside. Fuzzy means its core is like sludge. The helium and hydrogen in Saturn mix with more and more rock and ice over time the closer you go to the planet's core. It's similar to what you see in our oceans. The deeper you go, the level of saltiness increases. But the rings may disappear in the far future. Rings are generally more common than we think. Jupiter, Uranus, and Neptune all have their own ring system. But not every planet has the same ones. Saturn has a fascinating halo and definitely the most spectacular rings, true. Others mostly have rings made of dust and rocky particles, and not just planets. Other space bodies can have rings, like the asteroid called Chariklo. But even though the gas giants of our solar system have rings, rocky or so-called terrestrial ones don't. And one theory says it might have been that way because gas planets in the outer area of the solar system protected those rocky ones that formed in the inner solar system from all those collisions that possibly could have formed rings around them. Or it could be because gas giants are way bigger and their enormous volume allows them to have a ring system that can remain stable. And what if Earth had rings in the past too? Maybe in the time of the big collision when our moon could have been formed. Now to some more cool things happening in our solar system. Pluto, a tiny dwarf planet at the edge of our solar system, also the one we used to call a planet, has a pretty bizarre atmosphere. No one expected to see a haze there go as high as 1,000 miles. That means it rises higher above the surface of the atmosphere of our home planet. And the atmosphere on Pluto has around 20 layers. They're more compact and way cooler than scientists expected, and tons of nitrogen gas escape Pluto by the hour. But the dwarf planet still finds a way to constantly create new supplies of all the nitrogen it had lost. One theory says it probably produces these supplies through geological activity. Our moon is pretty peaceful, but that's not something we can say for Io, one of Jupiter's moons. This one has hundreds of volcanoes. It's the moon with the most volcanic activity in our solar system. Io sends plumes of sulfur up to an incredible 190 miles into its atmosphere. Its volcanoes emit many particles and gases into the space right next to Jupiter every single second. Its eruptive activities happen because of Jupiter's mighty gravitational forces and magnetic field. The insides of Io tense up and relax all the time, depending on how close or far away it is from Jupiter. And that's why it generates enough energy to have such an eruptive nature. Speaking of volcanoes, Mars has one larger than the whole state of Hawaii. At first, you'd probably say it's a quiet and peaceful planet. But once upon a time, enormous volcanoes dominated its surface. Yup, that includes a well-known Olympus Mons, the largest volcano ever found in our entire solar system. 374 miles across, comparable to the size of Arizona. Olympus Mons is 16 miles high, 3 times the height of our tallest mountain, Mount Everest. And by its volume, this volcano is 100 times bigger than the largest one on Earth. Mars can have such big volcanoes because its gravity is significantly weaker than the one on our home planet. Also, the crust on Earth moves all the time, unlike the Martian crust. Do you know how the Hawaiian Islands formed? A hot spot in the mantle created a chain of volcanoes in the crust floating above it. A Martian volcano may grow bigger because its surface isn't moving, so a volcano could build up for a longer time in just one spot. Miranda is one of the most bizarre moons in the outer part of our solar system. It's a shadowy moon that orbits Uranus, with many craters, sharp ridges, and similar disruptions on its surface. Usually, this type of relief tells a certain area used to have a lot of volcanic activities. But that wasn't the case with Miranda. Also, this moon is way too small to generate tectonic activities. Another element that could form this type of surface. One theory says the gravitational force from Uranus could have caused the push-pull action, something that made all these bumps on Miranda's surface. We'll have to send another spacecraft to find out what was happening there. We are all made of stardust. 97% of atoms we're made of are the same as the material our galaxy consists of. The building blocks of life is a term we use for a group of elements that are vital for life on Earth. And stars have these elements too, but in different proportions. For instance, we are 65% oxygen by our mass, whereas elements we measure in space, like the spectra of stars, have less than 1% of oxygen. So, Mercury is already the smallest in our solar system in the planet category, excluding some other bodies like the dwarf planet Pluto. And now it looks like it's still shrinking. It's the second densest after our planet, but it's getting denser over time. Researchers thought the Earth was the only planet in our solar system with tectonic activities for a long time. And now we know Mercury is tectonically active too. Messenger spacecraft managed to map the whole planet. Scientists realized the planet is full of fault scarps, some cliff-like landforms. Since these are relatively small, they're probably young, and Mercury is still contracting even 4.5 billion years after our solar system was formed.
You're relaxing in your room and streaming some good tunes when suddenly the network's down. You try rebooting your phone, but there's still no connection. Out of nowhere, your sister barges into your room in panic. She's screaming something about rings. Boxing rings? Wedding rings? Rings on the tub? She's not making any sense. So she drags you out of the house and shows you the sky. You take a look up and see streaks of objects forming miles above the Earth's surface. Her connection seems to work. The two of you check online what's going on, and everywhere the same thing is making headlines. Rings are suddenly appearing in our sky. #EarthRings is breaking the record, and videos are going super viral. Your sister can't help but join the crowd and takes a bunch of selfies with the sky. You run to the TV in your living room to check out the news. Scientists are warning about a coming catastrophe and explaining that everyone should remain indoors. Even though it's a cloudless day in the middle of summer, the weather seems to be getting colder and colder. Suddenly, the signal's cut off. Other channels show nothing either. Then you see your neighbors packing their bags and heading out. Others follow suit. You hesitate a bit, but decide to do the same in the end. Your sister is still outside taking selfies when you urge her to come along with you to seek some answers. The two of you hop in your car and drive out into the city. The rings above seem to be gaining more mass with each second. You and your sister are getting colder and colder. You head to the university to see if anyone knows anything, but there's no one there. Only one parked car in the lot. And it's a good thing you recognize that car. You and your sister rush in and find the astronomy professor doing some quick calculations and trying to figure out why all this is happening. He urges you to take seats and begins explaining. No one knows what this is all about, but it's limiting the sun's exposure on Earth, which explains why it's getting colder by the minute. Why the rings are getting thicker is a mystery too. On Saturn, the rings are made up of ice and rock particles. They can be as small as an ant or the size of a bus. The rocks could be leftover meteor debris or even remnants of dwarf planets. But since Earth is so close to the Sun, ice wouldn't be something you'd find floating above us. With all these rocks piled up, they block the Earth's access to Sun to warm us up and give us light. The professor goes on to explain that Earth will enter a new ice age, and oxygen levels will deplete within a year's time unless those newborn rings disappear anytime soon. This also explains why there's no connection. The rocks that form the rings are hitting and breaking the satellites. Suddenly, you hear a loud ringing noise outside. The three of you head outside and see a helicopter blasting an alarm with a red light flashing. Everyone to your homes now! This is not a drill! Everyone, head home! You get in your car with your sister, but the roads are jammed. You have to go on foot, which will take 2 hours. There's no way anyone can remain outdoors. You venture out seeing everyone stuck on the road. They're all arguing with each other and causing chaos. You try not to get caught in the middle of anything and sneak your way to the highway. With the rings getting thicker, less sunlight is breaking through. This Ice Age info is stuck in your head, chilling you even more. You take a deep breath and see a thin mist coming out of your mouth. The sky is getting darker and you're still not home yet. Your sister is tired and needs to rest, but you urge her to move on. You find an abandoned clothes shop and head inside. The store clerks are actually giving away thick jackets for everyone to wear. You grab a couple and slip them on. Only one more hour to get home, but the sky is completely dark. There's no way you and your sister can go out in such conditions, so you decide to camp up in the clothes shop. They set up a mini bonfire in the middle of the shop and create makeshift sleeping bags with the rest of the unused clothes. Luckily, there's enough food to feed everyone, including you and your sister. It's the middle of the night. The fire goes out and you can't see outside the shop. You head to the window and open it up. A huge pile of snow spills in and wakes everyone up. It's the middle of August, and a snowstorm formed overnight. Everyone is freezing, and they start the fire anew. There's no radio or any way to find out what's happening. The wind picks up and starts shaking the shop. Things start falling off the shelves, but you and everyone else are cozy by the fire. The next day, you look outside and see the entire area covered in snow. You live in a sunny place where it barely rains, and the rings in the outer atmosphere are even bigger than last night. Out of nowhere, a truck filled with people pulls over, and the driver tells you there's a shelter for everyone some miles away. The truck has chains all over the tires and is equipped for the worst snowy conditions. Even though it's morning, the sky is pretty dark. You and everyone else hop in. Abandoned cars, some with their doors still open, are scattered all over. The truck drives around them or just smashes through the ones in the way. It pulls over next to an ambulance and takes all the equipment to help the ones in need. You drive past your neighborhood and see your entire house covered in snow. The large tree in your backyard has fallen under the weight of the snow and broken the roof, allowing snow to flood in. The truck speeds through and gets to the shelter, which, to your surprise, is the mall. You get out and see many of the townspeople being led to various stores that have now turned into dorms and health units. You're left in a sports store with a bunch of other people. Your sister has also been able to bunk with you, and to your luck, you see the professor helping out some people. But shortly after that, a loud explosion blasts through the mall and shatters glass screens. Everyone ducks for cover. You see people running outside. You head out and see a large metallic object lying in front of the mall entrance. There are people crowding the entire area, so it's not easy to see what all the fuss is about. But after getting a closer look, you find out it's a satellite fallen from orbit. It crashed in the front yard and made the boom. There were also reports of other satellites crashing on Earth in the most random places. That means all communication has been wiped out of the map. You run back inside the mall to await what happens next. You look at your sister in fear, not knowing that the new Ice Age has just begun. One year later, you're relaxing in your bunker when your sister barges in, freaking out. The rings are still there, but it's something else now. You run outside and see everyone gathering around and looking at the sky. Within a year, temperatures have dropped to freeze the entirety of the Earth's surface. Deserts and tropical jungles have turned into icy wastelands. More than half of the wildlife went extinct, and trees are as rare as a four-leaf clover, which means oxygen levels have dropped significantly. Most of the population, or what's remaining of it, live with oxygen tanks, with scientists still trying to crack the case of the rings. Exactly what the professor predicted. But up in the sky, rocks seem to be falling down and crashing all over. It starts off far away, but then the rocks begin to fall down close by. You and everyone else run back into the mall, which has been covered with a layer of metal to keep the warmth inside. It should be pretty safe in there. If the rocks are falling down, that means the rings are dissipating. Suddenly, you're full of hope that the Ice Age might be over soon.